For the last part of naming ionic compounds, part 3, we're going to be learning how to name ionic compounds with polyatomic ions. Before we get into that, I just want to do a quick review. So, cations with only one charge, which we covered in part 1. So we have lithium and we have iodine. We get them together, it becomes lithium iodide. So lithium was a plus 1, iodide was a minus 1. Sodium here was a plus 1, oxygen was a minus 2. So I needed 2 sodiums to balance out that oxygen, and we just simply name it sodium oxide. Here aluminum was a plus 3, sulfur was a minus 2. Again, we had to find the lowest common multiple between these two, which was 6. Minus 6 and plus 6. And we call it aluminum sulfide. Okay, when we deal with cations with more than one charge, it is those elements that are colored on that periodic table that we've discussed before. So I know that oxygen is a minus 2 because I look at my periodic table, but I don't know what gold is. So in this case, gold has to be a plus 2. So we call it gold 2 oxide. Here, bromine is a minus 1 charge, but I have 3 of them, so this has to be a plus 3. So it could be iron 3 bromide. And in here we have that very special case with mercury. Fluorine is a minus 1, so that means I need 2 fluorines to make this a total of a minus 2 charge. This means that this side has to be a plus 2, and since I have 2 mercuries, each one is going to be a plus 1. So it's going to be mercury 1 fluoride. So I hope you guys know how to do these pretty well. Polyatomic ions is just one more step above it, and we'll learn by example. So basically when you have a polyatomic ion, so in this example I have lithium, which has a plus 1 charge, which I looked up on the periodic table. And if you remember your polyatomic ions, this is called nitrate, and it has a minus 1 charge. Since these two charges cancel each other out, I can just combine them to form lithium nitrate. And we name it metal first, and then when we name the polyatomic ion, we don't change it at all. It's just called nitrate, just like we learned it. Here we have a case of magnesium with a plus 2 charge, and this is what's called hydroxide. It has a minus 1 charge. These will not cancel out. Since I have a magnesium with a plus 2, hydroxide with a minus 1, I will need 2 of these to cancel out. So the way I write this is I will write this whole thing in parentheses and put a 2 on the outside to show that I needed 2 hydroxides to cancel out the magnesium. And since magnesium only has 1 charge, I'm going to call it magnesium hydroxide. Here I have aluminum with a plus 3 charge, sulfate, which has a total charge of minus 2. We have to find the lowest common denominator, which is going to be a 6. So I'm going to need 2 aluminums, and I'm going to need 3 sulfates. So to balance this out, I'm going to put a 2 down here to show that I needed 2 aluminums. And since I need 3 sulfates, I'm going to put this whole thing in parentheses and put a 3 on the outside. So that means I have 3 sulfates and 2 aluminums, and I name it aluminum sulfate. So these examples illustrate cations with only 1 charge. We're now going to do some examples when it has more than 1 charge. So when you have a cation with more than 1 charge, it's not any different from part 2 of our ionic compounds podcast. Here I have nitrate. Nitrate has a minus 1 charge. Since I only have 1 gold, this has to be a plus 1 charge to cancel out. And since gold is one of those that are colored, it's going to be a gold 1 nitrate. So we have to put the parentheses in the middle. Here I have a polyatomic ion called phosphate. If you look on your chart, it has a minus 3 charge. Since I needed 1 iron to cancel that out, this has to be a plus 3. So this is going to be iron 3 phosphate. again, to signify that that was a plus 3. And again, we don't change the endings of polyatomic ions the way we named them. Okay, here we got that infamous mercury. Which one am I using here? All right, so to dissect this, we will look up permanganate, and permanganate has a -1 charge. So, but I needed two of those. So that's going to be a -2 charge on this side. That means that this side has to be a +2 charge. Since I have two mercuries, it is the one that's the worst one to remember. This has to be a mercury 1 fluoride. All right, I want to give you some time to try a couple examples, and then I will go over them to see how well you did. So go ahead and click pause and try these out to see how well you do. All right, so in these examples, I have 3 of them where you have to name them, and 3 of them you have to give me the chemical symbols. So let's go over these and see how well you did. So KCN, K is potassium, and in CN is cyanide. Cyanide has a -1 charge, potassium has a +1 charge. They cancel each other out. Potassium cyanide, and potassium only has 1 charge, so that's how you write it. This is an element metal called manganese, which is colored. It has more than 1 charge, and this is what's called dichromate. And dichromate has a -2 charge. So if that has a -2 charge, that means that this manganese has to have a +2 charge. So we call this manganese 2 dichromate. Here's our wonderful mercury. We first have to look at the anion, which is carbonate. Carbonate has a -2 charge, and since I only have 1 mercury, that has to be a +2. So it's going to be mercury 2 carbonate. Okay, here we have to do the opposite. We given the name and you have to find the formula. So ammonium is a polyatomic ion, and ammonium has a +1 charge. So here's ammonium, and it's got a +1. Acetate over here, C2H3O2, has a -1 charge. So these two will cancel each other out, and you have ammonium acetate. And if you didn't memorize your polyatomic ions, you'll be completely clueless as to what this is. All right, here we have tin 3. So this definitely tells me the charge on this tin, which is a +3. Peroxide, if you didn't know, is actually an O2 with a -2 charge. So tin is a +3. Peroxide is a -2. That means I got to find the lowest common multiple, which is 6, which means I need two tins, and I will need 3 of these peroxides, and I put the whole thing in parentheses. Okay, last one is nickel 2 oxalate. Nickel 2, that tells me the charge on nickel, which is a +2. Oxalate is C2O4, and that has a -2 charge, so they cancel each other out. It'll just be nickel 2 oxalate. So I hope this helps you out learning how to name ionic compounds.